In this video, I am going to show you how to find the derivative function using the power rule. Uh, okay, so this is our power rule right here. And it says when I take the derivative of some function that equals x to the n, this is what I do here. So let's take a look at this. A function that looks like that might be something simple like x cubed. So that's in the form x raised to the n. And when I find the derivative, this literally says take the derivative, so I will take the derivative by bringing that exponent 3 out front, taking that 3 and subtracting 1 from it. And that's the beauty of calculus. Instead of those huge limit definitions to get a derivative, we simply have our little rule here and end up with the derivative of this function being 3x squared. It's pretty fast to go from the formula to its derivative using the power rule. Now, what the constant rule allows us to handle slightly more complicated situations, maybe something that looks like this. 4x to the, let's go to the fifth this time. And notice that this constant here just floats along for the ride. So when I take the derivative, I'm still using my power rule. I will bring that 5 out front, multiply, and that 4 is going to come along for the ride. And of course, I'm going to subtract 1 from my exponent because that's the power rule. And we'll simplify this a little bit. 5 times 4 is 20. And 5 minus 1 is 4. And this is the derivative of 4x to the fifth. And we get 20x to the fourth. So that is the power rule. The power rule with the constant multiple rule. Now we have a few other rules that allows us, again, to handle more complicated situations. And that is our sum rule and the difference rule. And what these rules allow us to handle is a situation that looks like this. Let's say I have f of x equals 5x to the third minus 2x squared plus 17x. In this situation, when I take the derivative, I can take this derivative term by term because this is really saying is I'm looking at each term as a separate either addition or subtraction, and then I can take each term's derivative one at a time, whether it's addition or subtraction. So what that looks like in application is when I take the derivative of f, again, I'm going to apply now the power rule term by term, and that's what this is saying. So with that, the first term, again, I'm going to bring that 3 out, multiply it by the 5, subtract 1 from the exponent. And the next term, I'm going to take its derivative independently. I'm going to bring the 2 out, multiply it by my 2 in front, and subtract 1 from the exponent. And oops, didn't mean to zoom in there. And last but not least is the derivative of 17x, which is 17. So now we can clean this up a little bit. And we end up with 15x squared minus 4x to the first plus 17. And the very last rule I want to talk about, which I didn't paste in here, which I should have, is that the derivative of a constant is 0. And if I had just looking at something very simple like y equals 8, well, what we're looking for in the derivative is the steepness of the tangent line, and this is a horizontal line, and its slope everywhere is 0. So it makes sense that the derivative is in fact 0. And of course, we can apply this to any part of a larger function. And when I take its derivative, again, I'm now using all of my rules: power, sum, and or difference, and constant. And again, I'm going to multiply that 2 times that 3, subtract 1 from my exponent, and the derivative of a constant is 0. And my final answer is 6x as my derivative of the function. And that is your power rule applied with the constant rule and the sum and difference rules of the derivative.